Okay, welcome everyone. Good morning, good afternoon, good evening. Welcome to the Kev Baker Show. A little belated start to the show today, but we got over some very serious technical glitches at my end, ladies and gentlemen. Windows decided to update yesterday and it's obviously reset all of the settings that it's taken me years to absolutely fine tune. But that's okay because we're here now and this is going to be an absolutely brilliant show today, folks. It truly is, because just prior to coming on air, how synchronistic, I was watching a video from the European Observatory which was showing a solar eclipse which was visible in some parts of the world today. And that's very apt for what we're going to be talking about today, because throughout time, the moon has been a constant companion of mankind, and it's been here, or it was here long before us, and ever since our time as hunter-gatherers, right up until this technological age, the moon has been with us through thick and thin. And when you talk about the moon, you could argue that without its presence in its shape, form, distance from the planet, etc., there's a case to be made that life itself may not even be here. And on today's show, we're going to be taking a look at the history of the moon, or at least snapshots of that history. And to help us do that, we're joined by Dr. David Warmflash. And Dr. David Warmflash is the author of From Ancient Myths to Colonies of Tomorrow, Moon, An Illustrated History. And David Warmflash, MD, is a physician, astrobiologist, space medicine researcher, science writer and communicator, and science lead for the US team of the Planetary Society's Phobos Living Interplanetary Flight Experiment. David is, quote, the stuff, or the star stuff that has achieved consciousness, as he puts it. So without wasting any more time, David, and I apologise for that shambolic start to the show because of all of the technical issues. How you doing, sir? It's great to have you on the show.
I'm quite all right. Thank you so much for having me on the show. It's an honor to be here.
Well, it was our mutual friend, Brendan Drackler, who said, Kev, there's this guy that you just have to get on the show. His name is Dr. David Warmflash. And to start with, I actually thought Brendan might be pulling my leg because I thought, what an absolutely fantastic name, especially for the topics that you cover, sir.
Sure. Well, I'm not even the only David Warmflash.
I noticed that today on Skype.
A couple of others. Yeah.
I was trying to add some on Skype, and they probably got some random messages from me.
Well, there are a few other cousins with the same name.
Excellent.
Distant cousins.
So I really breezed over your resume, sir. Before we get into the book, tell people about some of your background, because you've worked in some of the most amazing science projects.
Well, I have an MD, Doctor of Medicine, and I also had the opportunity to go into astrobiology, because when I was doing some training in Houston, Texas, there was an astrobiology program starting up with NASA, the NASA Astrobiology Institute, and there was an opportunity for postdoctoral training. And so I was in the first cohort of postdoctoral trainees, and my mentor was Dr. David McKay, the late Dr. David McKay. Unfortunately, we lost him in 2013, and he was involved when he was a lot younger. He had been involved in the training of astronauts to do geology on the lunar surface. And then later, he was part of the beginning of the Astrobiology Institute, and he is the researcher who discovered what seemed to be fossils, microfossils, inside the meteorite ALH 84001, Allen Hills 84001, which is a meteorite that originated on Mars.
Cool.
And so I've been doing a lot. I mean, I'm doing science communication. I've been doing astrobiology. Oh, you mentioned the project, the Phobos Grunt project. That, unfortunately, is now at the bottom of the Pacific Ocean off the coast of Chile. It was launched on a Russian mission that was supposed to go to Phobos, one of the two moons of Mars. And the reason why we were on that mission was the mission itself was supposed to collect samples of Phobos, and we were piggybacking on the mission so that we could have several different organisms representing all three domains of life on Earth, eukarya, archaea, and bacteria, uh, to see how the interplanetary radiation environment and the weightlessness and everything else about spaceflight outside of the Earth's protective geomagnetosphere would affect the organisms. And we just needed to have a lot of time in interplanetary space to simulate a human mission to Mars. And so that was going to Phobos, and we decided to send it on that mission. We, meaning I and colleagues at the Planetary Society.
Yeah, that's one of the things we often talk about here on the show, whether or not humans can thrive and even survive for longer periods off this planet, because it's almost as if we're kind of tuned, we're set up to be here. We've got the Schumann resonance, things like that. We're used to gravity being the way it is. And, when you start stepping off the planet and going further afield, even in our own solar system, I mean, that raises the question, can we even live there?
Well, precisely. There are a lot of unknowns. We assume a lot. There's a lot of people who want to colonize Mars. I would love to colonize Mars. We don't know yet, though, about reproduction in low gravitational fields. The gravitational pull at the surface of Mars is only about 38% of what it is here on the surface of Earth. Now, if we were going to colonize, let's say, Venus, we cannot colonize the surface of Venus because the atmospheric pressure is too high. It would crush you. And because the temperature is ridiculously high. But the cloud layers in Venus, there's a certain range of altitudes that you can get in the Venusian atmosphere where you could have floating colonies, and you would have the Venusian gravity, which is only just slightly less than Earth gravity. You don't really need to do a lot of research to know that that'll work okay. If it's, say, 0.9 or 0.85 of a full G, I'm not too worried. But when we get down to 38%, when we get down to the 16% gravity on the moon, we need to do some experimentation first because we just don't know. What we do know is that the gravitational vector has an influence on embryology and pregnancy and the orientation of first the embryo and then the fetus within the womb. So before we go colonizing those places with children and families, we have to work that out in some other studies. As for the radiation, that's an issue too, except we'll probably be burying habitats underground, so we'll have good protection from the radiation.
Absolutely. And you mentioned the moon there, and what a time for us to be speaking about the moon, because like I said to Brendan last night, here we are approaching the 50th anniversary of the Apollo mission. And of course,
Yeah.
that was something that set the imaginations of people around the world alight when it came to the moon. But the moon is nothing new, sir, and you put together an absolutely fantastic, I would say, collection of almost short stories, illustrated short stories, 100 of them. That,
That's right here.
yeah,
It's
that
just like this.
it really pieces together. I mean, when I was looking at this today, and I'm not going to dare say I managed to read it all, but I kind of flicked through it, and it really is the kind of the facts. If you're having a conversation about the moon, anyone who's got this book is going to be armed with the most interesting conversation pieces ever, because you've taken it, you've created a timeline, and you've
Yeah.
broken it down. And let's go back to the very start. How did the moon officially, or what's the kind of official line on how the moon
Sure.
formed?
Yeah, well, actually, that'll even tie in with a lot of the history that might interest a lot of the listeners in the UK, because one of the researchers uh, in the late 19th century who had one of the key hypotheses about the origin of the moon was George Darwin, son of naturalist Charles Darwin. So it was part of it. It was the 1870s, and the two leading hypotheses at that time, first was one by Edward Albert Roche, a French researcher, who had an idea called co-accretion. that the Earth and the Moon both formed in space from roughly the same materials at the same time, and you ended up with the Moon orbiting Earth. And then a few years later, toward the end of the 1870s, George Darwin had a different hypothesis to challenge that. His idea was called the fission hypothesis with Osmond Fisher. The idea was that the Moon came from the Earth. He thought it came from the Western Hemisphere, resulting in the Pacific Basin, that when a big chunk of the Earth's mantle was flung out because Earth was spinning a lot faster than it's spinning today, he thought, well, that made a giant hole that became the Pacific Basin. Now, we wouldn't even consider that today because we know that the reason we have a Pacific Basin is because the continents are spreading out between, well, North America and Asia are spreading out. No, I got that backwards. North America and Asia are going the other way toward each other as North America and Europe and Africa are spreading out. The Atlantic is getting bigger. So they didn't have the theory of continental drift in Darwin's time. So it really wouldn't make sense today, but it was something that made sense to him, even though there are several problems with it. If you get down to the physics, to the geophysics, and some of the details, and also some of the results of what has been found looking at samples from the Apollo lunar samples that astronauts brought back from Earth.
Yeah, because it was when the Apollo astronauts started bringing the samples back that we really got a time scale on things, wasn't it?
Yeah. There was a theoretical understanding of what the time scale should be because of what they were finding out about Earth. But Apollo confirmed everything and gave us more information, including information on other possible explanations for the origin of the Moon, such as the next hypothesis that came into play, which was in the very early 20th century. Now, I should say that before that, the Darwin hypothesis about the Moon being flung, a big part of Earth being flung into space, that actually dated back way to ancient times to Anaxagoras, the Greek philosopher who figured out how eclipses work, how a solar eclipse and how a lunar eclipse work. He had an idea that the Moon had begun as a rock flung into space by Earth. He didn't talk about the Pacific Basin or anything like that, but it was, in a certain sense, kind of a forerunner to the George Darwin hypothesis. Then, in the early 20th century, Thomas Jefferson Jackson C. had an idea that came to be called the capture hypothesis, wherein you had the Moon came from further out in the solar system and somehow got captured by Earth's gravity and then went into orbit around Earth. And then in the 1970s came the Hartman and Davis hypothesis that's come to be known as the giant impact hypothesis, where the Moon began as a result of a collision between the early Earth and another planet that had been around, a Mars-sized planet that scientists like to call Theia, for the daughter of one of the Titanesses, the Moon, the daughter of the Moon goddess, Selene. The mother of Selene, the Moon goddess. And so you get a little connection out of Greek mythology there. And the hypothesis, the basic idea is that there was a lot of mixing between the two worlds, and that the Moon ended up being composed mostly of a lot of Earth's mantle material. And that's supported to some extent by results of the Apollo missions that show that there's agreement between certain isotopes, especially isotopes, between Earth and the Moon. But there are other things that we found out that actually conflict with this hypothesis. In the time, it was thought to be very, very likely, because when the Apollo samples were initially analyzed in the 1970s, there was no evidence of water anywhere or any kind of volatile substance. And if you had a crash between a Mars-sized planet and Earth, close to 4.5 billion years ago, the heating would have been so intense and the melting of both worlds so intense that the moon would have lost all its volatiles, and it should be totally dry. There shouldn't be any water on the moon. And that seemed to be what they found. But because of better technology coming around the early 21st century, they were able to find that actually those samples that didn't seem to have water molecules actually did have water molecules. And the water is buried very deep into the samples within a mineral within the samples, a mineral called olivine. And so it doesn't exactly jive with the giant impact hypothesis. And so now it's possible that the community of lunar scientists might gradually start moving over to another hypothesis that came out a few years ago from the Weizmann Institute in Israel, Oded Aronson, the idea of, well, there are impacts involved in forming the moon, but instead of one giant impact, it's a whole lot of small impacts happening that put material into space orbiting Earth, and then that coalesced into the moon.
Well, that would account for the isotopes matching, because from what I understand, I mean, that's almost like a fingerprint, right? It would be very, very
Exactly.
rare for it to have been captured, say, and then turn up with the same isotopes involved, right?
Right, exactly. It is like a chemical fingerprint.
Cool, cool. So now, just recently, well, I say just recently, there was a mission that sticks in my mind, and I think it was called the Lacrosse mission. Now, I think that's where NASA, the way they worded it on the internet was they were kind of bombing a projectile at the moon, and it was said that the moon rung like a bell after that. What's your thoughts on that?
Well, that's been going on since the early space age. They've been banging things into the moon, and that's how they get most of the information about the internal structure about the moon, about its geophysics. They intentionally crashed pieces of Saturn, the upper stage, the S4B stage, on several missions, and they set it on course. After the booster had gotten the astronauts on course for the moon, there was a little bit of fuel in it, and they could control it. And so they would set these boosters to crash into the lunar surface once they already had some seismic instruments in place to take readings. And from the beginning, from at least Apollo 12, they had seismic instruments that were still operating. There were some seismometers set up on Apollo 11, but those didn't operate for a very long time. They also crashed the ascent stages from the lunar modules down at the Earth after they finished using them, after they brought the astronauts back up to the command modules. And they also had thumpers, which were little mortars that would explode things on the surface of the moon, and that could be picked up by the seismometers.
Hold that thought,
also
David.
with information.
Hold that thought.
Wars are psychological just as much as they are physical, just as much as they are economic. Listen up.
We tax you your peace of mind. We construct lies to make them true. We tell it, we sell it, you buy it, I get mine. There is no greater money maker than
Welcome back, ladies and gentlemen. Today's special guest is Dr. David Warmflash, and he is the author of the brilliant book Moon: An Illustrated History. Now, when I was looking through this today, I was really interested to see all of the stuff about calendars. There was Sumerian calendars, and then I came across one that really was a lot closer to home, right here in Aberdeenshire, sir. Talk to us about this Aberdeenshire calendar.
Oh, that's the oldest lunar calendar that is known. It's 10,000 years old from the Mesolithic period, which is a transition between the old Stone Age, when people lived in hunter-gatherer situations in caves, and the Neolithic, when agriculture was invented and they were moving toward civilizations. And it seems that we have evidence that people were thinking of the moon way back into the old Stone Age from things like 12 or 13 lines being carved on the bones.
Oh, you still there, David? I hope David's still there. There you go. You're back.
Okay,
You're back.
I know that whenever a phone call comes in, I could stop it. So people are interested in the moon. And the moon is an obvious calendar because it comes in cycles and you can look at it. But also the solar year is an obvious calendar because the seasons are changing. You go from one winter to another winter. But people were always looking for ways to get the lunar cycles somehow in sync with the solar year. And the earliest that we know that happening is in this Aberdeenshire calendar. It's a series of an arc of about 12 pits carved into the ground with different phases, the different phases of the moon carved in so that you can follow the phases throughout a month. And then along with that, there's a notch that in rocks. And if you look through that notch on the calendar, on the day of the winter solstice, the sunrise lines up exactly with that notch, which shows that the people who built it had a way to get the lunar cycles into sync with the solar year, which is remarkable for that period, that they were actually able to do something like that. And it was something that then for millennia after that, different civilizations were always trying to do that. And it took another few thousand years before finally, initially the Sumerians, and then in a much more organized way, the Babylonians got it down to a very, very precise synchronization that is with us today in the form of the Jewish calendar, which works on a 19-year cycle in which there are a certain 1 month added to the year as a leap year. And that happens out of every 19 years, you add an extra month, make a leap year for 12 years, while the other 7 years are each 12 months without adding a month.
So is that actually a more accurate measurement of time then than the kind of Gregorian one that we stick to?
Well, they're both accurate today, but for ancient times, there were different reasons why different civilizations would want to use one or the other or something else. So, in ancient Egypt, they used the star Sirius, which is the brightest star that appears in the northern hemisphere. And what they did was it's the brightest star in either hemisphere. And the timing of the rising of Sirius was in sync with the flooding of the Nile. So the Egyptians didn't need the moon so much as a calendar the way that the people in Mesopotamia needed it, or the way that the people in Scotland needed it. And so in Mesopotamia, they were using the moon. They were timing, they were looking at the lunar phases that go through cycles of approximately 29 and a half days. And as things got more organized in the Bronze Age and then into approaching the Iron Age, they found in the Sumerian cities that we're going to have to alternate between months that are 29 days long and months are 30 days long, because you can't have a month that's 29 and a half days long. And so it went from that to around, it really started to get organized in the third dynasty of Ur, roughly the year 2100 BCE something. And then a few hundred years later, under the domain of Hammurabi of Babylon, it got even more organized, where there was a mandate to alternate between 29 days and 30 days months. And then 1,000 years after that, there was a Babylonian ruler named Nabonassar in the 8th century BCE. And he, if anyone could be called pro-astronomy, it was Nabonassar. He commissioned a whole bunch of astronomers to look through data that went back for centuries. Now, how do they have data? They had clay tablets and they cuneiform writing, and they would look through records of where the sun was in the sky, where the moon was in the sky, where different planets were on different dates, and they mined those data to look for trends, and they came up with two very huge discoveries. One was a calendar that they were able to put in the sync between the lunar and solar calendar. They found that every 235 lunar cycles, you'd get a repeat of the solar year. And that's 19 years, 235 months. It's a cycle where you have 12 years of 12 months and 7 years of 13 months. And I think I said the opposite a few minutes ago, but this is the correct way. So every 19 years, you're going to have an extra month added to 7 years. And that way, whatever is happening according to the lunar calendar will not be thrown out of whack. Now that comes down to us. The Greeks had an astronomer named Meton a few centuries later, and that was then called the Metonic cycle. And it also worked its way into Judaism as the Jewish calendar. And that's why a Jewish holiday that comes at a certain time of the year might shift around a little bit. Let's say Passover will shift around between March and April, but you'll never have it in January or July. In contrast with the Muslim calendar, where the holidays will shift around the entire solar year. So you might have Ramadan in May, and then next year you'll have it in April, and next year you'll have it March-ish, and February, and it'll be in the summer, it'll be the winter. That's a pure lunar calendar, as opposed to the 19-year lunar solar calendar. And it's a little bit interesting how you sometimes see this worked into the mythology, where you've got the number 19 coming up in a biblical story even, versus the number 360, which is the number of days in the Egyptian solar calendar. That came into the story of David and Saul having a battle against one another.
Yeah, because you even cover like the lunar cults of the Bible
Yeah.
as well, don't you?
Yeah. Yeah, sure. I mean, there's a famous story about the book of Joshua when there's a war and there's the sun stops and the moon stops. But the story is not merely, the sun stopped and the moon stopped. First of all, it is a quotation from a pre-existing book. The writer says very clearly, the way we would put a reference, we'd cite bibliography, and the writer says, does it not say in the book of Yashar that the sun stopped at Gibeon and the moon in the valley of Ayalon? So what is this book of Yashar? This is some ancient book on which the writer of that part of the Bible was writing and using as a source. It seems to have been a poetry book because the lines that are cited are poetic. Sun stands still at Gibeon, moon in the valley of Ayalon. Now those are actual places in Israel. Gibeon is an archaeological site that was known to be associated with a solar cult. In the Bible, the story of King Solomon, he gets into a lot of trouble with the hardline religious people because he's offering sacrifices to a solar deity at an altar in Gibeon. And well, it sounds like the Valley of Ayalon, which also is a real place, maybe there was a lunar cult there. There's always symbolism about the moon versus the sun. We got symbolism in this story about David and Saul that I mentioned. There's a battle in which David's side loses 19 men. In other words, Saul's side kills 19 men. And then King Saul's side loses 360 men. So one of those kings represents the sun, and one of those kings represents the moon. Is it about them fighting about lunar god versus a solar god? Or are they fighting about, no, I think we should use the solar calendar. I think we should use the lunar calendar. The back and forth between the sun and the moon, it almost makes me think of the back and forth between, in modern times, going from one United States presidential administration to another, should we send people back to the moon or should we go directly to Mars? That's our analogy of a change in policy today.
No,
You also,
I really like the way you put that there. Yeah, that makes a lot of sense.
you also, I mean, there's a very overt reference to the moon and the sun in a dream sequence of the character Joseph, the Hebrew Joseph in the earlier Joseph in the Hebrew Bible, the son of Jacob, where he dreams of his father Jacob as being the sun and his mother Rachel as being the moon. And that's really interesting because the story of Rachel, the matriarch, has a lot of other lunar symbolism in it. For one thing, when she's trying to hide some little statuettes that she stole from her father, in order to keep her father from finding out, she tells him he can't come into the tent to see what she's doing because it's that time of the month for women, she's menstruating, which for ancient people, they thought that was connected with the moon. And there was a whole novel written called The Red Tent, about how this was really determining the lives of the Hebrew characters, the Hebrew female characters in the Bible. Also, her father's name, Lavan in Hebrew, Laban in the English pronunciation, it meets one of the words in Hebrew that means moon. And her father, Laban, and Rachel, and their whole family, they come from the northern Mesopotamian city of Haran, which was in fact the location of a temple to the lunar god Nanu-Sin. He was one of the most worshipped lunar gods of ancient Mesopotamia. And on top of that, the name Rachel in Hebrew, Rachel, when it's written in the ancient Canaanite text, which is the form of old Hebrew letters that would have been used in the time that this was written centuries ago, before the Judahites that became the Jews went into the Babylonian exile, that differs in that writing by only one letter from the name of a Canaanite and Mesopotamian moon goddess, Nihal. So it's just it's not absolute proof, but it's just a pile of circumstantial evidence connecting the mother of Joseph, Rachel, with the moon.
No, that's really interesting. And, I want to stick with ancient times because today, like
sure.
I was saying, there was this absolutely amazing eclipse in the sky, and it always leaves me in awe. It truly, truly does, David. And I was going to ask you about how the ancients viewed solar eclipses and what role this played in determining that we were actually a solid planet, a round planet ourselves.
Mm-hmm. Well, yeah. Well, first of all, you didn't even need an eclipse to learn that Earth is a round planet, because
so when did that? Because you hear about back in ancient times, they thought it was flat and things like that. When was it determined scientifically that we're on the ball?
It was determined without a shadow of a doubt by the time you're approaching the classical period of ancient Greece.
Okay, because a lot happened during that Greek period, and I didn't appreciate it today until I listened to you and Brendan, and also thumbing through this book of yours as well.
Yeah, there probably were people living long before the classical period of Greece who had some kind of inkling that Earth must be curved, because especially among the Phoenicians, because the Phoenicians were mariners, and if you're a sailor, you're going to realize that, say you're approaching an island or you're approaching a city from the sea, if it's not flat ground, you're going to see something that sticks up to a higher altitude, such as a tower or a mountain. You'll see the top of that first before you see the sea level area of the island or whatever it is. And the same thing, if a ship is approaching, you would see the mast, the top of the mast, before you see the hull of the ship. And that was one line of reasoning that Aristotle would use when he would put together various lines of evidence that Earth was a ball and that it was not flat. But another one that he used, which was probably realized a century or two before he wrote all this down in an organized way, was that if you look at the shadow of the Earth as Earth begins to eclipse the moon, then the shadow is curved. And it doesn't matter what kind of lunar eclipse and what direction it is, it's always a curved shadow. And the only form that could cause a curved line, a curved shadow on the moon when the Earth is making the shadow is if it's a sphere or if it's spherical. And then later on in Hellenistic times, there was a Greek scholar who actually didn't discover that Earth was a sphere. It was, assumed it was by that time. But he actually measured the circumference. And that was Eratosthenes, who was chief librarian at the Great Library and Museum in Alexandria, Egypt.
Cool, because you've got a chapter about the Library of Alexandria as well.
Oh, yes. Yeah, it was all the everybody who was anybody in that part of the world, in the Greek world, and scholars from other lands. They were all working at the library, because that was the time after the Empire of Alexander the Great had broken off, and Alexander had united culturally and also in terms of administration a whole, really, two continents. He brought Asia together with the eastern part of Europe all the way to the Mediterranean. And so there were people traveling long distances to study at the library. And now one of the people there was Aristarchus, who figured out that Earth orbited the sun and not the other way around. But a little bit after his time, Eratosthenes, who was the chief librarian, was reading a book. And there were a lot of books in the library because it set out to collect hundreds of thousands of different books from all over the world. And whenever there was a ship that would come into the Alexandria harbor, the Alexandria police, one of their main jobs was to board these ships and confiscate not drugs, not money, but books, and take the books to the library to be copied as papyrus scrolls. And one day, Eratosthenes was reading a scroll, and he read something that fascinated him. He read that if you travel up the Nile River, which means to the south, and you travel a very long distance, you get to a place, it's modern-day Aswan, but it was a city called Syene. And that on a certain day of the year at noon, and it turned out that this was actually the day of the summer solstice, that on that day at noon, in that city, way to the south, there was a certain well, and the sun's rays would shine directly down into that well. And that was not something that happened in Alexandria. And also on that same day, a pole in the ground that's sticking straight up from the ground would not cast a shadow, which meant that the sun was directly overhead. And Eratosthenes knew that, well, here in Alexandria, we never get that. We know that the shadows change their length. They get longer, shorter, but we never get a shadow that just disappears because the sun is directly overhead. So he knew that based on the length of the shadows and knowing the height of a certain towers and sticks, that he would be able to calculate the amount of curvature or arc between here in Alexandria and over there in Syene. And he calculated that there was what we would call about a little more than 7 degrees of arc between those cities. So approximately 1/5 the arc around a circle. 1/50th the arc around a circle, which meant that all he needed to do was find out the distance to Syene and multiply that by 50, and he'd have the circumference of Earth.
Wow.
So then all he had to do, now how was he going to calculate the distance to Syene? There were maybe a few different ways he could have done that, but he did it. He may have used a kind of odometer that Archimedes had invented, or possibly he may have just hired somebody to pace it out.
Well, imagine
People
that.
would do that in those days.
But you know, getting back to the moon as well, and the Greek. I mean, this is a level of thinking that really, with the education system we've got today,
Yeah,
I don't know how long we'll
yeah,
be producing thinkers of that ilk again. But if we get back to the moon, one thing that's always fascinated me, Doc, is the fact that it's just the perfect size and it's just the perfect distance away for us to have
yeah.
this amazing display when we get these eclipses. Now, I don't
Yes.
know. I mean, don't get me wrong, okay, but there just seems to be something engineered about that. You know, it's just too good to be random, right?
Seems that way sometimes.
Yeah, I mean, how does that happen? I mean, is it something to do with the gravitational forces of the sun and the earth
Yeah.
that it just
Well,
happens to?
it has mostly to do with the gravitational forces between Earth and the moon. It's the tidal forces. And the moon used to be a lot closer to Earth than it is today. It may have been 15 to 25 times closer when the moon first formed. And so the gravitational attraction between the moon and Earth was a lot stronger. This was billions of years ago.
Yeah.
And so the moon would have looked enormous in the sky. And it's because of that, the tidal forces between the Earth and the moon are what cause the ocean tides, which is a kind of a stretching of the oceans, but it also stretches the solid substance of the Earth. It stretches the rock, and it stretches the rock in the moon. But it's mostly because of the stretching of the ocean that the moon has been moving constantly further away. Because what that does is it creates bulges in the oceans, and because the gravitational force happens immediately, but the buildup of the ocean bulge kind of lags behind, and the moon and the Earth is spinning. When that happens, you end up with the bulge being a little bit of ahead of where the moon is in its orbit around Earth. And because the bulge of the ocean is a little bit ahead, the gravity is a little bit stronger from the Earth, just a bit ahead of the moon, and it pulls the moon forward. It accelerates the moon.
Yeah, so
This is called,
it almost falls into
yeah,
like a gravity well
yeah,
per se.
and it goes faster. And because it goes faster, it moves out to a higher orbit. It very gradually spirals outward. It's happening now about 3 to 4 centimeters per year. And we can measure that very, very precisely because of instruments that astronauts during the Apollo program placed on the lunar surface. Apollo 11, Apollo 14, and one other mission, I think maybe 15. They put special reflectors that would reflect back a laser beam back in the same direction from which it came. And now you can shine a laser beam on those instruments and take very precise measurements about how fast the moon is moving away from Earth, and also even how fast the continents are sliding around on Earth. So it's been used for studies of continental drift.
So we're almost on the break, Doc. Now, let people know
Yeah.
where they can find your book and where they can keep up with your amazing amounts of work, sir.
Well, the number of places where you can find it are increasing.
Good.
So if you're in the United States, it's at every Barnes and Noble store. Of course, it's on Amazon, and it's on an increasing number of independent bookstores. I can name some in specific places, and then in Canada, it is in recently entered the bookstore chain Indigo. It's on there, and of course, it's on Amazon. I hope it's in some other stores as well. In the United Kingdom, it's certainly on Amazon, and I hope it will get into brick and mortar stores.
Fingers
Tell
crossed. Yeah.
your store owners of your favorite store to get the book.
Well,
Show them
you
the
know,
book.
it's one of the
But for
most
now, you can
the
get it online.
yeah, the moon is always a popular topic, and because I've got a YouTube
Yeah.
channel as well, I know that when you talk about the moon, you'll get more listeners, more viewers, more people interested than say a number of other topics. So I really hope we can get this book out there because, folks, this is the
Yeah.
kind of thing that you can. There's so many factoids in there, and the illustrations It's amazing. Now, when we come back from the break, I'll be asking the doc what would happen if the moon wasn't here. Our number 2, ladies and gentlemen, with Dr. David Warmflash in the house. What a show this has been so far. We got off to a bit of a ropey start thanks to updates on my computer, but it was well worth the wait. And we've been kind of looking at the history of the moon, looking back at ancient times as well. And we're going to be moving forward. We're going to be looking at the space race, the moon landings. Yes, still a controversial topic today. We'll be getting David's take on that. And then we'll be projecting forward as well to something that's come up a few times on the show recently in Project Artemis. But before the break, I was saying, David, what would happen? And you were saying there yourself, albeit very slowly, the moon is moving away. And in introduction tonight, although it was kind of flipped on its head because of all the issues that were going on, but I was kind of suggesting, and I will ask you this question, would life even be here without the moon?
Well, we don't know. It's really hard to come to a conclusion when we have only one datum, life on Earth.
Yeah.
We're looking for a second datum in biology, which maybe could be life on Mars, if it's actually different life and not the result of meteoroids taking life from one planet to another. That's the same life with the same genetic code. But or could be something in the ocean of Enceladus, or one of the moons of Saturn, or Europa, one of the moons of Jupiter. Or it could be something we find from observing other star systems, looking at chemical signatures in the atmospheres of extrasolar planets. So what we have is just hypothesis. And assuming that the origin of life took place on Earth, rather than Earth being seeded from somewhere else, we do know that because the moon was a lot closer to Earth than it is today, that the ocean tides would have been a lot bigger than they were today. Instead of being measured in meters, they would have been measured in kilometers. And that would have been a lot more mixing between land and sea, which meant molecules of organic molecules being deposited to dry up on the seashore, but further out, and then the tide coming back and bringing it back in. So it's possible that maybe because of the mixing, there could have been an influence of the moon on the origin of life. But somewhat more certain is perhaps the moon's influence on the emergence of intelligent life. Because unlike microscopic life, which can be extremely tenacious, can live through, there are microorganisms that can live inside nuclear reactors, such as one species called Deinococcus radiodurans, that my colleagues and I sent out on the Planetary Society mission into space a few times to look at how life works in the space radiation environment. They will live inside a nuclear reactor. It's very tenacious. But the same cannot be said for human life. We're very sophisticated, and we've had probably come close to extinction a few times, and certainly large multicellular organisms before there were humans came close to extinction. And because of the moon, we have a stabilization of the Earth's wobble. So what this means is that Earth is spinning on an imaginary axis that actually wobbles. It wobbles. If you spin a top on a table, it'll spin, but as it goes slower, it'll start to wobble as it spins. And it's because of that wobble that we have a procession of stars. The constellations don't exactly all go exactly in the same direction over this cycle that's many thousands of years. This was discovered.
Yeah, is this the precession of the equinox? Yeah.
Exactly. This is a precession. It was also discovered by an ancient Greek, Hipparchus. He didn't really know the reason for it, but he discovered it, and it's a result of the Earth's the axis that points not exactly in line with the plane of the orbits that Earth forms in which Earth goes around the sun. It's not exactly perpendicular to that plane. It's not parallel with it either. But if you imagine an axis perpendicular to Earth's orbit around the sun, it's off on an angle that varies between about 22 degrees and 24 degrees. Right now we're at 23.5 degrees. And it's because of the moon that wobble between 22 and 24 degrees is not a lot bigger, let's say from 12 degrees up to 30 degrees or something like that. And it's huge on Mars, which doesn't have a big moon. It just has two tiny little moons. So in a way, Mars is kind of a control condition. And the seasons on Mars, there's huge variations of seasons. And if it were not for the moon acting as a kind of stabilizer, the shifts in climates over this many thousands of year period in the precession would be a lot bigger. Ice ages would be a lot more severe, and then Earth would get hotter in a more severe way, would go back and forth, and the climate would be shifting to such an extent it's very questionable whether this would have been survivable for our ancestors or if it would be survivable today. And there may not have been time for brains to evolve to the point that we have anything like a human being.
Absolutely. And here we are. We've evolved to the point where we went from looking at the moon, mapping it on the ground with stones, to an age where literally we were reaching out and going to the moon. And of course, we're in the month of July 2019 here, 50 years on from that famous July date. And I find it quite synchronistic. I think it's pretty cool, Doc. You've got Apollo 11 took off on July 16th, and that's my birthday as well. So, yeah, absolutely. Twice the reason for me to celebrate. But talk to us about the space race and us reaching out for the moon, because this is another massive part of your book. You've really catalogued this as well. When did we first think? When was the first talk about going to the moon?
Well, people imagined it, of course, long before there was a technology to go there. Since we're shifting topics, could I just say really quickly, because we were cut off before on the break, when you were asking me about where people can get the book, I didn't want to leave out the other half of the planet that listens to you. So in Australia and South Africa, New Zealand, so they might want to get the book too. And also there's the online availability of the book. You can get it online. The countries that have Amazon, you can get it there. So Amazon is kind of, I know there's Amazon in Australia, and I don't know about some other places how you do Amazon in
for some reason,
New Zealand and South Africa.
We're a big hit down in Australia. A lot of Australian listeners, and I love that. The Australian people are great. So I don't know what it is with Scotland and Australia, but there's definitely some kind of a brotherly love going on there.
Yeah. I hope our friends in Australia will get it online and maybe convince the book chains there. I forgot what it's called. It begins with a D, but get it into those stores. Ask those stores to carry it. They do have an arrangement with my publisher, so they just have to want the book and put it in the stores, and it can get in the stores there.
That's it. We'll send out that message to Australia right now. Get this book over there.
Yeah. So, but the space program, there were ideas about, well, Plutarch, the Roman literist, biographer, philosopher, he thought that the souls of dead people traveled to the moon. But much later, Johannes Kepler, the astronomer, the astrophysicist, who really one of the people who brought astronomy into the modern age. And there's some really interesting stories that I have in the book about him and about Tycho Brahe, who was the guy who hired him, who really got him started in a big way. Some amusing things in there. But Kepler, when he was younger, he wrote a story about a person who goes to the moon, which unfortunately got his mother, Katerina Kepler, into a little bit of trouble with the law, because the way that the character in the book gets to the moon is that his mother's a witch, and the witch kind of casts some spell on him, and he goes to sleep and has a dream that he travels to the moon. We would call that a fantasy story or a science fiction story today. But unfortunately, maybe because people were reading that story, they said, aha, Kepler's mother must be a witch. So she was arrested for witchcraft. She was almost executed, but Kepler was also an attorney, and he was able to get her off. But she was in jail for something like 6 years before they finally let her out.
Wow. See, I had
Yeah.
no idea about that at all. I mean, Kepler's a name you hear all of the time because of the telescope
Yeah.
and things, but no, I'd never had
Yeah.
that insight into the character himself.
Oh yeah, I mean the Kepler telescope, the Kepler planet finder, is named for him. He has such an amazing history, not only in the fantasy about the moon, but just what happened between him and Tycho Brahe. Do you ever talk about him, about the Danish astronomer? Had some crazy ideas and was such a colorful figure. I mean, the reason he was such a famous astronomer was because he discovered a supernova. One day he just looked up. He was one of these astronomers from kind of a minor lord in Denmark, and he knew every star and planet where it's located like the back of his hand, so he could just look up in the sky and know what should be there. And one night he looked up and he saw some hugely bright light, way several times brighter than the planet Venus. And he saw that, and it turns out that what he saw was a supernova. And now it's called Tycho's star, Tycho's supernova. For a few days, it really was brighter than Venus, and then gradually kind of subsided. It can still be seen today. This made him really famous. And so the king of Denmark gave him a whole island, which is now part of Sweden, and for him to build a big observatory with all the state-of-the-art equipment of the time. And on that island, he developed his idea of the cosmology, which was kind of a weird cosmology that he had. And this was soon after the Copernicus idea about the planets and Earth orbiting the sun, which was a revival of the idea that went back thousands of years to Aristarchus of ancient Greece. But when Copernicus published that, and floated around for a few decades, and then Tycho Brahe thought that, well, I don't think that Earth is moving, because he had a way to measure very precisely whether there was parallax between different celestial bodies. Parallax means that if you look at something out in space or even nearby, then if you change the angle from which you look at it, it should appear to shift around. So if you look at some object really close in front of you and you cover one eye like this, and then you move your hand to the other, you'll see that it kind of shifts around. And the whole argument, going all the way back to Aristotle, centuries ago, before that, was that there's no stellar parallax. As you go from, let's say, January to July, we don't observe any changes in the relative positions of stars of different constellations. And Aristotle could not understand why you would not see that if Earth were moving around, unless the stars were just so crazy far away, which is what another Greek thinker 100 years after Aristotle thought, Aristarchus. He said the reason we're not seeing that shifting is because the stars are ridiculously far away. In fact, they're so far away, they must be suns themselves, and they must have planets with life forms. But people paid attention to Aristotle, who said Earth is stationary, not to Aristarchus. And that went on for a while until Copernicus. Although there were some hints of people in the Arabic-dominated period in the Middle Ages thought that maybe that Aristarchus was right. But after Copernicus published his idea, Tycho Brahe read it, and he thought he had the best astronomical equipment in the world, and that he was the best astronomer. And he said, if I, Tycho Brahe, cannot measure any stellar parallax, then it can't be that Earth is moving. It must be that it is stationary. But on the other hand, he thought that Copernicus' idea about the planets orbiting the sun was very intriguing. He thought that was correct, and that there was evidence for that. And so he decided that the planets must all be orbiting the sun except for Earth, and that the sun must be orbiting Earth and then dragging all the planets around it that are orbiting the sun. And that was his model of the universe. And it really took Galileo a little bit later to shift the idea back toward what Copernicus really thought.
And much like Kepler's mum got in trouble, I mean, Galileo,
yeah.
he got in trouble himself for some of his ideas, right?
Oh, he sure did. And then what Kepler did was provide the mathematical framework that would allow the Copernican idea to be true. Because Copernicus was deadly wrong about one thing. He thought that the planets went in perfect circles around the sun. And that model, mathematically, it actually wasn't any better than the model of Aristotle that was given a mathematical framework by the astronomer Claudius Ptolemy, with a lot of tweaking by some different Arabic astronomers over the centuries. But what Kepler discovered was that, no, the orbit is not a circle. It's an ellipse. It's a stretched out circle. And that was a key discovery. And the reason he was able to discover that was because Tycho Brahe gave him a job. So what had happened with Tycho Brahe, he was a character. He was so always having these big elaborate parties. He wasn't the nicest person. And he had a slave that he would force to eat under his table. He had a pet elk, and he liked to entertain his guests. He would get the elk drunk, feed beer to the elk, until finally one night the elk just fell down the stairs and died. But Tycho also had a metal prosthetic nose. And the reason he had a metal nose was because he lost the real nose when he was a young man, when he was a lad, as you say, sword fighting in a duel with a cousin. But they weren't fighting over a girl. They weren't fighting about anything. They were fighting about who was a better mathematician. And each of them was convinced he was the best mathematician of the land. And so he lost his nose, and he had this metal nose. And eventually he had his own observatory, but he had to leave the observatory that the King of Denmark had given him, because after the King of Denmark died and his son was replacing him, and it may be the reason that it turned out that the astronomer Tycho got into trouble with the new king, the prince, the son of the other Danish king, that Tycho seemed to have been shagging the queen, the mother of the new king. And so he was thrown out. He lost his job, and then he had to go do astronomy somewhere else. And the Holy Roman Emperor in Prague then said, why don't you come here and build a new observatory here? And so he built a new laboratory, a new observatory, where he's trying to prove his idea of the planets all going around the sun while the sun goes around Earth. And so he hired Johannes Kepler to work with him. And Kepler had to get out of where he was in Graz, Austria, because of fighting between the Protestants and the Catholics. And Kepler was a Protestant, and the Catholics were about to just go through the whole area and murder all the Protestants they could find. So Kepler got this job working for Tycho. But Tycho was a little bit worried about letting Kepler know. He knew that Kepler was pretty smart, and he didn't want to give too much information. He didn't want to give out all of his data.
I mean, Tycho must have known. He must have suspected that his model was wrong, and confirmation bias and just pure denial must have kept him in that mindset, right?
Well, there was a lot of confirmation bias, but so what happened was that his data showed that looked like Venus was going around the sun, and it looked like other planets were going around the sun, but the orbit of Mars just looked crazy. It didn't fit in with his idea about the sun going around Earth while everything else went around the sun. And so he put Kepler in charge of that. He told Kepler, look, you work on the Mars data and come back to me and let me see if that proves my idea. my model of the universe. And Kepler thought, oh, I can solve this thing in a week. And Kepler thought that Copernicus was right. He didn't think, he thought, what's this crazy idea of Tycho Brahe? But it was a job, and he needed the job. And he ended up working on it. It took him years in the end. But in the meantime, Tycho died. And there are all kinds of different stories about how he died. And they're just as crazy as the stories about how he lost his nose. It could have been that this was a very common story. He was having a big feast, and he had the emperor over for a feast. And the etiquette at the time was that you do not stand up from the table and leave the table before the emperor leaves. And while they were all drinking a lot of beer, and Tycho was drinking a lot of beer and wine, and he really had to go to the bathroom, and he had to pee, and he just held it in, and he kept holding it hour and hour until finally his bladder exploded, and he had a massive bladder infection, and he died because of that. But there are ideas floating around that maybe he was murdered, that maybe Kepler murdered him. Because what happened in the end was that Kepler inherited the observatory and inherited all of Tycho's data and used those data to figure out the laws, Kepler's 3 laws of planetary motion, that really turned astronomy around and moved everything in the direction of real scientific astronomy, setting up things for Isaac Newton and gravitation.
Yeah, because I noticed that in the book as well today as well. You've got these characters in there. Newton, of course, he factors into this as well, right?
Big time, yes. It was the moon that inspired him, because what really motivated his gravitational thinking and how he developed gravitational theory in his Principia was that the moon is falling, and the gravity is the force that's actually making the moon and planets move. But something had to be making them move. Kepler was able to figure out the mathematics of how to predict where a planet would be, how fast it's going, but it wasn't a real theory that explained everything. And with Newtonian gravitation, you can actually derive Kepler's 3 laws of planetary motion.
No, that's pretty cool, man. Very, very cool. Now, we're going to be coming up on the break in a moment. We've got one more segment to go, and I hope we can get to the kind of space race after this, the Apollo mission, and, of course, the upcoming missions that NASA have got planned as well.
Yeah.
And just the other day, before we go to the break, they were announcing, is it Dragonfly, where they're going to be sending the quadcopter up to Titan?
Oh, to Titan,
yeah.
yes.
What do you think about that? That's quite exciting, right?
Oh, yeah, it's it's really astrobiology mission, because it's going to be looking for molecules of life and looking for biosignatures.
Now, do you think Europa might even be a better candidate than Titan for life with the liquid oceans under the ice?
It was very hard to access the ocean.
Yeah.
So you got to drill through ice or find some way through the cracks and get a submarine in there. Maybe an easier target is Enceladus, because with Enceladus, you got geysers that are shooting the ocean contents out into space, and you could just collect it.
And of course, with the likes of SpaceX, Blue Origin, and all these other private companies now, it's almost like the possibilities are endless. And myself and Brendan, I mean, we always talk once a month about how excited we are when it comes to space, because it seems like back when Apollo happened, there was obviously the big race to get things going, but it almost feels like we're having an echo in time, because a lot of talk about future space missions, other countries as well, David, going to the moon and beyond.
Yeah, and even naming the program to return to the moon for the sister of Apollo, ARTEMIS.
An interesting name. What do you make of the choice of name then?
Well, neither Apollo nor his twin sister were the nicest gods. So Artemis, it was her idea to go on kind of a massive murdering campaign against the children of Niobe, she and her brother. But really, she was the one who felt insulted and decided to murder these 7 daughters and 7 sons of Niobe. But well,
You see, this is why
These are
NASA end up getting a bit of shtick. They choose these funny
maybe.
names for projects and things like that, and that makes people question their motives. You see?
Yeah, yeah. Well, they name them after. Well, most people don't really know the details of the stories of these Greek gods and goddesses. Some of them were nicer than others. So,
That
uh,
that's one
yeah,
kind of gap I've got in my historical kind of knowledge. That the whole Greek kind of period. It's something that when I was looking again at your book today, I was fascinated to see what an influence they really had on obviously science of the time, but even up until today as well.
but at least Artemis was more lunar than her brother. The Apollo has solar associations. He's either he's the god of light, and he's a kind of a sun god, where Artemis is a kind of a moon goddess.
Well, at least she's going home then by
Yeah.
2024, maybe. Now we're
Yes,
almost on
that's
the
right.
break, so folks, remember to check out the book, Dr. David Warmflash, and the book is called Moon: An Illustrated History. Welcome back, ladies and gentlemen. I'm your host, Kev Baker, and we're moving into the final part of today's Kev Baker Show with a new and very special guest, Dr. David Warmflash, and he is the author of the book Moon: An Illustrated History from Ancient Myths to the Colonies of Tomorrow. And I've got the PDF form of this. I'm waiting for the actual book to arrive, and I can tell you, folks, it really is. It's all the ammunition you need if you're having a conversation about the moon. It's almost broken into like 100 short stories with 100 images. And yeah, it's absolutely brilliant. Now, let me just say though, folks, I apologise if I seem slightly off my game tonight. If you were here at the start of the show, you'd have known there was some real technical issues, and it's from my end here. And yesterday, Windows informed me it had the latest groovy update for Windows 10. And me, stupidly, I went and installed it without maybe going to check first if there was any known bugs. And obviously, I've done something to the sound setup on my PC. Usually, when you're doing these shows, us radio hosts, I'm not a radio host, I'm just a dude with a microphone. But usually, we can hear ourselves talking. And when you first start doing this, that sounds really weird and it's really hard. You kind of get used to it. But I tell you what, see now that I'm doing it without being able to hear myself, it is so, so weird. It's almost like I don't know if this is even going out at times. But I've got David Warmflash with us. He'll be back in just a moment. He's away to get something to eat very quickly. But we're going to be getting into the moon. And this is obviously the subject matter of his book. But we're going to be talking about the moon landings because obviously later this month it's the 50th anniversary of the Apollo mission that took us to the moon. Or did it? And I'll be asking David about his thoughts on why we did go to the moon when he comes back in just a moment. And I'll be sharing my opinion, what I think happened with David, and we'll see what he has to say about that. We should get a couple of laughs and jokes along the way, because I've still got a serious issue with that thing called the Van Allen radiation belt. But I'll be able to ask David about this. He's worked with NASA, and of course, 2 nights on the trot now. I'll be accused of being a NASA shill, right? And I find it quite funny, folks. People will say that, and I think that's why myself and Brendan, we kind of play on it when we get together. It might annoy some people, but we just like to have a bit of a laugh and a bit of a joke. And here he is. He's back with us. The man himself, Dr. David Warmflash. Definitely the coolest name that I've had on the show, Doc. Definitely. But before the break there, or just after the break when you were away, I was saying to the audience, we're going to get into the moon landings. Now, obviously, this is a very important month. It's the anniversary. And I'd love to get your take on the Apollo mission, in particular, Apollo 11. But here's where I kind of lie on this, and you can make of this what you will, because there's a lot of controversy. Did we? Didn't we go to the moon? And I'm a bit of a strange one, because I think we did go to the moon. And at the same time, I also think that what we've seen as the moon landing was filmed for propaganda purposes. And the reason I say that is because we were so up against the Russians at the time. Imagine the PR disaster if something had gone wrong. So they had a backup, something that they could show, as opposed to maybe something going wrong live. But at the same time, I do think we went there. Now, that said, before I hand it over to you, I've got a serious problem with these Van Allen radiation belts. And I know you're going to be able to explain this in greater detail to me. So the moon landings, am I going mad? Am I one of these tinfoil hatters?
Well, you're not. You're not going mad, because if there were any mistakes that could have been done to throw people off, to kind of trigger a little bit of paranoia, NASA made those mistakes. Like, one really classic example is with the flags. The pole on the top part that was supposed to hold the flag was made too short, and as a result, the flag ended up having to be kind of accordioned on there, so it gives an illusion that it's blowing or something. And the people who thought that NASA didn't send people to the moon, they latched right on it. They said, aha, you see, look at that, there's wind there, so it can't be real. And a lot of little things like that. They have a part where they're jumping, and they filmed the jumping because the camera was on the other side of the equipment, so it's perfect for people to say, oh, well, maybe they're hiding a trampoline back there, and that's why they're jumping like that. Little things like that. But one important thing is that the Soviet Union was a big factor in this, and that the Soviet Union would have loved to have any kind of hard evidence that the missions were not real. And what they had were these special ships in the ocean that tracked astronauts, NASA astronauts, when they're in space. They tracked them on certain frequencies, and they had to aim the equipment out to whatever direction the American spacecraft was in order to track them. And they did that the whole way to the moon. They aimed it out as they went to the moon, and then went behind the moon when an Apollo command service module was orbiting the moon, and it was telling them exactly what you would expect if a craft were out there and following that sort of pathway to the moon and then around the moon. And then in terms of signals coming from people on the surface of the moon. And in order for NASA to fake that, they would have had to launch satellites to the moon, going there and making all those signals. So it's possible to fake that, but the everything that you would have to do in order to fake it would be more of a complex situation than actually just going to the moon.
You're going to have to go there anyway to put the satellites there, so you might as well just do it. Yeah. And what about the Van Allen radiation belts then?
Yeah, well, the Van Allen belts. So this is a common talking point for the people who worry that maybe we didn't go to the moon, where they say, wait a minute, how could they get through the Van Allen belts? So the Van Allen belts are concentrations of trapped radiation, of particle radiation that's part of the galactic cosmic radiation, and also that's part of radiation from the sun. And they include particles such as protons, and then larger charged particles like helium nuclei, and even larger, very large charged nuclei called Hz particles, which are not good for you. And so the common talking point is, well, how could they have traveled to the moon? They'd have to go through this and be exposed to all this radiation. But the answer is they weren't exposed to lethal doses of radiation. The Van Allen belts, there's an inner belt and there's an outer belt, and there's also a third belt that lights up only when there's a high solar activity, and they didn't even know about that belt. But the highest concentration of the most lethal radiation is in the inner belt. And when astronauts traversed that belt, they navigated in such a way that they're only going through a small corner of the inner belt. And the way they went to the moon, they were mostly coast. So at the beginning, going from low Earth orbit to the moon, they would light up the S4B stage, which was the upper stage of the Saturn V, and get a very, very high acceleration. So at the beginning, they were going very close to almost 40,000 kilometers per hour, or 25,000 miles per hour, close to escape velocity, which would take them through that little corner of the inner belt within minutes. And then they'd go through in a longer time a section of the outer Van Allen belt. And for each of those, including the greatest concentration of radiation in that little corner of the inner belt, they would avoid the parts that had the worst radiation. And they were wearing radiation detectors just like any other radiation workers would wear, like people who work on a nuclear submarine, people who work at nuclear power plants, wear these sensors. And on the last two Apollo missions, Apollo 16 and 17, there were also biology experiments called Biostack 1 and Biostack 2, which actually told scientists how many Hz particles were going near little single cellular organisms, near shrimp eggs, near some plant seeds, and they found it wasn't really that great. And in terms of the radiation sensors that the dosimeters that the astronauts were wearing, what it told physicians and scientists was that in transversing the worst part of the Van Allen belts, since they went through very fast, they got a dose somewhere in the range of about 10 millisieverts to 15 millisieverts, which is about what you would get if you're getting a computed tomography scan of the abdomen or the chest, not even what you get on a full body CT scan, a CAT scan. So yes, there's a tiny amount of risk there, but it's not the kind of risk in the range of what's going to give you acute radiation sickness where you'll just die. It's something where you get a slight increase in your cancer risk over many decades, just like if you get a CT scan for any kind of medical condition or an injury.
You see, I've never had it explained like that, and I mean, I think when you hear radiation belt, I think people of my age anyway, we automatically word association. We think it's like something out of Chernobyl when it started, when it was
right
at the height of its problem, you know. So that's really a good explanation there, and I thank you for that. So
Chernobyl makes the crossing the Van Allen belts look like absolutely nothing.
See,
it just looks like I got to put on my sunscreen kind of thing.
That gives people a good way of explaining it, how they can visualize this. And you mentioned the Saturn V there, and of course that rocket now. Would we or would America have got to the moon when they did if it wasn't for Wernher von Braun? And of course he came over after World War II. How influential was his kind of knowledge in taking us to the moon?
Well, Wernher von Braun himself, it's really hard to know whether, let's say you had his entire team without him.
Yeah.
There were a few people working with him that were brought over from Germany that knew a lot of what he knew. But it's clear without the Saturn V or something like it derived from the V2 rockets that they were working on in Germany, that without that, there's no way we could have gotten to the moon with people as soon as we did. Now, bringing up the Van Allen belts, if you look how different countries like China and India and Israel have sent recent probes to the moon, they don't just go zoom really fast through the inner belt in a few minutes with a low dose radiation the way that they did it with the Saturn V. They don't have Saturn Vs, so they got to take a slow scenic route where they gradually spiral outward, and there you're going to get a much higher radiation dose compared with what you have with something like a Saturn V. So I don't think if we had to go like in a very slow trip, taking a few weeks to get to the moon, especially back in the 1960s, that they would have been able to do it that way. It really was the genius of von Braun that enabled us to do it, and it wasn't even clear though that we'd be able to do it even with his idea, because there were other people that had to come into the picture with suggestions about how to go. When they initially got the mandate from President Kennedy to go to the moon, von Braun thought we were going to use an enormous rocket, even bigger than the Saturn V. He wanted to build a rocket called Nova, which would have been so large that they weren't even sure that the astronauts would be able to land it on the moon and be able to see where they were going, and that the surface of the moon, the regolith, would even support the rocket. They were going to land the entire ship. It was called direct ascent. They thought, send the whole thing to the moon, with everything you need to land back on Earth and then bring it back, because they didn't have any idea how you could rendezvous between different ships. And then later there was an idea called Earth Orbit Rendezvous, which ultimately von Braun decided, well, that might be a good way to go to the moon. Have a few launches of a Saturn V and have them meet up in low Earth orbit, and then send a ship to the moon and then have it come back to Earth that way. And those were the popular ideas. And there was another idea that someone a while back had come up with, and then an engineer named John Hobolt had latched onto it, and he was not the highest up engineer, and he kept pushing for it. He went above the authority and went kind of behind the back of his own boss and right up to Siemens, the deputy administrator of NASA, and pushed for, we have to do lunar orbit rendezvous. We got to bring just a small ship with us that'll go down to the surface of the moon, and just with some of the astronauts, and they got a rendezvous. And he gradually convinced the NASA leadership that this is what we have to do, which meant that they had to learn how to do in-space rendezvous. And that was a big part of the reason for the Project Gemini, for getting ready to go to the moon. Because they couldn't do that with the initial little ship they had called Mercury. All that did was take one person up into orbit and then come down. They couldn't change orbits. They really couldn't do much of anything.
Of course, you've worked at NASA. You've spoke to some of these astronauts. I mean, any interesting kind of anecdotes about space missions along the way?
Well, there are some interesting anecdotes about from some moon missions, and especially if you want me to connect some of the medical components in there, that led to a few little, even some amusing things that happened. So some were serious and some were both. So there was actually a case of cardiac arrhythmia on Apollo 15, which is very serious, because there were serious arrhythmias that could have been life-threatening on one of the astronauts while on the surface of the moon. And it was a thing where today this couldn't happen because the astronaut turned out that he had underlying cardiac disease that would be easily detectable today, and that person would be screened out of the program and wouldn't go to the moon. But they thought initially, when seeing these arrhythmias show up on the cardiac monitors in Houston, they thought maybe the astronauts are not getting enough potassium. Maybe it's hypokalemia, low potassium. And so they made sure that on the next mission, Apollo 16, that the astronauts would take in plenty of potassium. And the way they decided to do that was to give the astronauts fruit juice, not Tang, but other fruit juice that was spiked with extra high amounts of potassium. And they had to keep drinking this all through the mission. But the thing about potassium is that in epithelial cells that line the intestine, there are certain little molecular pumps that will interchange potassium for hydrogen. They'll hold on to it the same way. And so they'll exchange potassium for hydrogen, for protons. And when the potassium leaves the intestines to go into the bloodstream, hydrogen comes out and accumulates in the intestines, which meant the astronauts would get bloated. They get full of gas, which would lead to a lot of flatulence, which actually is potentially dangerous if you're inside a spacesuit in an enclosed environment. If there's a lot of hydrogen gas building up in there from flatulence, then you could even have an explosion. So no, it's not just amusing, but it became amusing because while on the lunar surface exploring, the commander of Apollo 16, John Young, well, he had a case of this, and well, you were in the military, isn't that right?
Yes.
So the language that of say fighter pilots and test pilots, it's not always the most clean language. There's some salty language they're used to using with one another. And so John Young was exploring the lunar surface. How much of what he said word for word am I allowed to say on the air on your show?
Yeah, go for it. Go for it.
Pretty much anything. Okay,
yeah,
so
go for it. Yeah.
He's with his friend, his crew member Charlie Duke, and they're on the lunar surface, and all of a sudden Young starts saying, "Oh no, Charlie, I got him again. Got the farts again." And then he starts talking about the fruit juices. He's like, "I'll tell you, when I get I'm not having any more fucking fruit juice for the rest of my life." And he goes on dropping the F-bombs all over the place until somebody from the control center of Houston kind of chimes in. He's like, "John, you got a hot mic." So, and he was broadcasting basically to all of humanity is listening to this conversation about his farts.
We've got a saying over here in Scotland. We've got a saying in Scotland, as popular as a fart in a spacesuit. And the next time I hear that, well, I'll have a different take on it altogether.
Really relate to it.
Definitely.
Now, so Houston tells him, "John, you got a hot mic," and John's is just like, "How long have we had that?"
Now, before we go, I know that you've written an article about should we quarantine the moon. Now, I liked reading that article because you were basically kind of talking about the potential for setting it up as almost like a sterile scientific lab. Now, I know we're getting ready to go back to the moon ourselves, but I like that novel idea, maybe sending robots up there, set up some laboratory. Yeah. What's your thoughts on the moon and the future, where we're going with it?
I think the main take-home message of the article, based on the expert comments I got and the investigation, was that it would be very impractical to quarantine the moon, but we might want to quarantine things coming into the Earth-Moon system. It's really hard to know how to do this. Probably the best place to do a really reliable quarantine, ironically, is on Earth, because we have ways to set up barriers with very high technology, and then to look at samples. Let's say we have samples coming from Mars. It's a lot easier to set up a level 4 biohazard facility and make a kind of what really would amount to a level 5, where we also protect the samples from being contaminated from Earth, so we can study them for astrobiological purposes. It may be easier to do that on Earth than to do that on the moon, because we'd have to move a lot of heavy equipment to the moon.
So, living on the moon long term, like we started off in opening the show, are humans able to live out in space for long periods of time in our current shape and form?
Well, we know from the International Space Station that we can keep people in a spacecraft environment for a year or more. The Russians have had people for a long time. We had Scott Kelly. We on the American side had Scott Kelly, and there have been other European astronauts for long periods of time. Excuse me. Well, but there are certain particular challenges when we get to the moon. The lunar dust might be a very big challenge because it's like little sheets of glass. It's sharp, and we have to learn how to keep the dust out, and it sticks to everything. And we know it was eating away at spacesuits on the Apollo missions, especially those J missions. The last 3 missions were heavy on geology field work, and also had to keep astronauts on the moon for 3 days with an extravehicular activity, spacewalks on the moon, one day after another. And during debriefings of surviving Apollo astronauts in the early years of the 21st century, one of the constant recommendations were don't make lunar explorers do 3 lunar spacewalks in a row, 3 days in a row. Don't do more than 2 in a row, because it was really pushing the limits of what they can handle in terms of minor injuries, such as their knuckles having the skin worn out and starting to bleed, and their other parts of the body being kind of worn and torn, and even wear and tear on the spacesuits. And there was also a big recommendation that you must fix the gloves, that the gloves really were very difficult to work with. So it could have been that on those J missions that given the technology that they had on the Apollo mission, they might have been pushing the limit as to how long they could stay on the moon in terms of how all the instruments worked and the human performance issues, the human factors issues. And that when we go back, I mean, theoretically, there shouldn't be a problem with keeping people, as long as they're protected from radiation by being underground or being inside lava tubes, but keeping them there for long periods of time, just like we keep people in Antarctica or keep them on the space station. But we're going to have to look very carefully at the human factor setting. We'll also have to look very carefully about the spacewalks from the point of view of the decompression sickness stressing, because they're going to have to be much higher workload spacewalks, and we'll have to look at the protocol really carefully. We're really good at preventing decompression sickness from people working in spacesuits out at the space station, but because of the increased stresses and the lunar situation or lunar missions, we might have to work harder at that. But it could be that the advanced spacesuits will help a lot. One thing they're trying to develop is a high-pressure spacesuit where it has about twice the pressure, the atmospheric pressure that a spacesuits of the space station era has, and that helps reduce the risk of decompression sickness also. There are just a whole lot of, it's technology that will help a lot with all of this.
And we're almost out of time, unfortunately, Doc, because I could geek out with you for hour after hour. But let people know again where they can find the book. And I urge everyone to check this out.
Yeah, well, in virtually most of the countries that can hear you, most of the English-speaking countries, and a lot of the non-English-speaking countries, and a lot of the big European countries like Germany, the Netherlands, Spain, Italy, they all have their own Amazon sites. So the most universal place where you can get the book is Amazon. You can also get it in the Barnes & Noble online, although I don't know about ordering it outside the United States from Barnes & Noble. Canada has also, in addition to the online sites, there's a chain in Canada, the Indigo book chain, and in the United States, the big book chain Barnes & Noble has it in the actual stores. There's several bookstores. I just heard of a bookstore that has it in a part of Oregon called Hood River. Just told me there's a store there that begins with a W. Sorry, store, I can't remember what your name is. And there are a bunch of others. But in Australia, you can get it on Amazon, and in of course in the UK on Amazon. I hope soon, if it gets to be really popular in the UK, I hope it'll go into the Waterstone.
We're out of time, Doc. We're out of time. I'll be back after the break with Joe Joseph. Wherever you are, make it TFR.
How it looks.